Hi everyone. In this video we're going to continue section 6.2 and look at some other examples of solving equations. I'd like to do some harder ones with you as well as some which have answers which are expressions and not numbers, and then we'll also talk about contradictions and identities. Alright, so here's an equation with fractions. We have several options for how to solve this, and you may have one that you're already comfortable with and prefer. Go ahead and use that, but let me give you one option if you don't have one that you would naturally tend to go towards. So that one option would be to clear the fractions. Alright, well, how do we do that? Well, if we multiply by the least common denominator, or least common multiple of all of the denominators, then watch and see what happens. This will clear the fractions and then we don't even have to deal with them. Alright, so let's look at the denominators. We have 3, 5, and another 3. So we need the least common multiple of 3 and 5. Well, those are both prime numbers, so the least common multiple is just 3 times 5, or 15. Alright, so now if we multiply the entire equation by 15, okay, or by 15 on both sides, then what we need to do is distribute that to each of the terms. Alright, so this is like 15 times 2x over 3, 15 times x over 5, and then 15 times 26 divided by 3. Alright, now I prefer to divide and then multiply. Alright, so at this stage you can either do 15 times 2 divided by 3, or you can do 15 divided by 3 times 2. Okay, so either way you'll end up with 10 for the coefficient, and then we still have an x. Alright, and then this is like 15 over 1. Alright, so it's like 15 over 1 times 1/5, and that's 3. Okay, and we still have an x. And then here I would do 15 divided by 3 is 5, and 5 times 26 is 130. Okay, and so notice now the fractions have cleared. We have denominators of 1. Alright, they're not even written here. So now we can just proceed as normal. So 10x plus 3x, we would combine like terms. And then divide both sides by 13. And we see that the answer is x equals 10. Alright, let's try another one. Okay, so first of all, the denominators. We have 3, 2, another 2, and then we do need to consider the denominator of the 4. If there's nothing there, that would be a 1. Alright, so we're looking at the denominator of every single term. Alright, so here, 2 of these are prime numbers, the 3 and the 2. 4 is not, so let's go through if you ever need to do this with larger numbers. To find the least common multiple, you basically want to break each number down into primes and then look for things that they have in common. Alright, so we have a 3, a 2, and then 4 is 2 times 2. Alright. Now if there's anything that either 2 of these numbers or all 3 of them have in common, we just use that once. Alright, so we have these two 2's. Alright, so use a 2. And then we just throw in all of the leftovers. So we've got this one and this one. And multiply everything. And that equals 12. Alright, another option is to just start listing multiples of each of these and just see what the smallest one is that they all have in common. Alright, so for 3 we could do 3, 6, 9, 12, etc. Okay, 2, 4, 6, dot, dot, dot. 4 would be 4, 8, 12, dot, dot, dot. Okay, and then eventually you're going to see that 12 is the first number that they have in common. Alright, so let's go ahead and multiply this equation by 12. Alright, and basically we're doing 12 times every single term. Alright, so let me write that out. Okay, and then you can go through and start doing this multiplication. All right, and so we end up with 12 divided by 3 is 4. And then I'm doing 4 times 2x minus 3, so this is the distributive property. So 4 times 2x is 8x. 4 times negative 3 is negative 12. Okay, here we have 12 divided by 2 is 6. And 6 times 5x is 30x. Okay, 12 divided by 2 is 6, so 6x. And then the last term, 12 times 4 is 48. Okay, and then from there you would just treat this like the other equation examples that we've done. So I would start by combining like terms on the left. So 38x minus 12 equals 6x minus 48. Okay. And then you have a couple options here, so let's maybe subtract the 6x. Move that to the left, so we get 32x minus 12 equals negative 48. Then add 12, and you get 32x equals negative 36. And then divide by 32. And then the last thing we need to do is put this in lowest terms. So these can both be divided by 4, the numerator and denominator, and that gives negative 9 over 8. Alright, and you can leave it like that, or you can make that a mixed number if you prefer. Alright, let's do an example of solving where the answer is not actually a number, it's an expression. So we want to solve the formula A equals T1 plus T2 plus T3 all divided by 3, and we're solving for T3. So here when we say solve, we don't mean find the numerical value of T3. We basically just mean get T3 by itself. So we just want to use algebraic properties to try to rewrite this equation so that we have T3 equals and then something else on the right. Alright, so what do we need to do to get at that T3? Well, there's a couple things that are with it. We have a T1 and a T2 added to it, and we have a T3, or we have a 3 that's in the denominator here. Everything's divided by 3. Alright, so let's clear that 3 first, and that's kind of a good idea just in general when you have fractions. Might want to try to clear those. So if we multiply everything by the least common multiple of the denominators, which is 3, then you get 3a equals T1 plus T2 plus T3. Alright, and just if you're interested, notice this formula may look a little bit familiar to you. Alright, maybe if I tell you that A stands for average, alright, so maybe T1, T2, and T3 represent 3 different test scores. Alright, so how do you find the average of 3 test scores? Well, you just add them up and divide by how many there are. Divide by 3. Okay, so let's see. So we've moved the 3, and now we need to move the T1 and the T2. Alright, so basically I just need to subtract them since they're added to T3. And I'm just going to do this all in one shot to save a little bit of time and space. Alright, and then you can write this left side in any order that you prefer. I'll put the positive term first, the 3a. Okay, and then minus T1 minus T2 equals T3. Alright, same thing if you prefer, you can kind of rewrite this so that T3 is on the left, but you could also just leave your answer like this. Alright, how about this one? Do you recognize this formula? This is for converting Celsius into Fahrenheit. Alright, so let's solve this for C, and basically we should end up with the formula for converting Fahrenheit into Celsius. Alright, so we have addition and the plus 32 and something multiplied by C. Alright, so we'll go backwards with order of operations. and I will move the thing that is added to it first before I move the thing that's multiplied to that c. All right, so subtract 32. Okay, and then you have two options. You can divide by 9/5, or you can multiply by 5/9. I like that one, so that we don't end up with a fraction in a fraction. All right, so the 5s and 9s cancel, or 9/5 times 5/9 is just 1. So that leaves you with a c on the right. And then on the left, you can distribute that if you would like, the 5/9, but sometimes you'll also see this formula just written as is, so we can leave it like that. Okay, and then we've solved for c. So again, notice it's not a number, it's an expression with variables, but we've isolated c, we've gotten it by itself. All right, the last thing I want to talk to you about is contradictions and identities. These are two types of equations that you may encounter. A contradiction is an equation with no solution. All right, so you should see this because as you're solving, you'll see a statement which is a contradiction. So you'll see something like 3 equals 5 or 0 equals 7. All right, something which cannot be true no matter what x is. And then that's your clue that this has no solution. And then what we can do is just describe the solution set. So you've got a couple ways to say this. You could say no solution. All right, or sometimes we write this using set theory notation. And do you remember how to describe nothing in terms of sets? That's an empty set. So you can write the set of curly braces, or you can write the symbol for an empty set. Okay, so that's the set of all of the numbers that would make the equation true. There are no real numbers that will make the equation true. And actually, when we say no solution, I should probably correct this a little bit. We should probably say no real solution. Okay, it may have an imaginary one, but we're not really considering those in this course. Okay, and then an identity. That is an equation that is true for any value of the variable for which both sides are defined. Okay, so in other words, we could have something that looks like 3x equals 3x. Okay, and that's true all the time as long as x makes both sides of the equation something that's defined. So in other words, x needs to be a real number in this case. You can't just plug in like an infinity symbol or something like that, that has different rules than the real number system. All right, so you'll see statements like that. You may see things like 7 equals 7, all right, but things that are true all of the time. Describing the solution set. Okay, again, we have a couple ways to describe this. We could say all real numbers, right? Or we could use that set theory notation. Right? We have a symbol for the real numbers, the set of real numbers, and that's that fancy scripted R. All right, so let's try it out. Decide if the equation is an identity or a contradiction and write the solution set. All right, so we're looking for two things here. Right, one, state which it is, and then write the solution set. That's number 2. All right, so in part A, what you want to do is just try to start solving this, and then it should become apparent that we have an identity or a contradiction when we reach one of those two types of statements. All right, so we would probably distribute the 3 first. Okay, get 3x minus 18 plus 2x equals 5x minus 18. Combine like terms on the left. All right, and then you can keep going if you like, but you can actually even stop just right here because the two sides of the equation match. So as long as x is some sort of a real number, then this will always be a true statement. All right, so this is an identity. and that means that the solution set is all real numbers. All right. Now notice somebody else may have chosen to solve in a different way, so you may get different statements. It doesn't matter which statement you get. All right. So for example, let's say next you added 18 to both sides. Then somebody else could get the statement 5x equals 5x. That's still also true all of the time. Maybe next you subtract 5x from both sides. All right, and then you get 0 equals 0. Right, so notice all of these are true statements. They're just different. Okay, and then the second statement. So let's try to start solving. And I would start by combining like terms on the left. 8x minus 4 equals 8x minus 10. All right, and you may even be able to tell right away what type this is. Let's say you go one step further, subtract 8x, and you get negative 4 equals negative 10. And now you should definitely see what type this is. That is false all the time. That is a contradiction. Okay, so then the solution set would be the empty set, or no real numbers. All right, that's the end of this video. So we've talked about solving equations that have fractions involved, solving equations where the answer is an expression and not a number, and then how to recognize contradictions and identities and state the solution sets. All right, thank you for watching.